I choose optics because even as a young boy, I was interested in astronomy and in telescopes and things like that, and was building small telescopes. So I studied physics, and I had an offer for the Institute of Technical Optics in Berlin. And they had no students at all because nobody wanted to go to optics. Optics at that time was an old-fashioned and not a science which is worth doing it. But I went there because I was interested in optics. And a couple of years earlier, the laser was invented, and the holography was invented. And a couple of years after I started, optics became a wonderful research field. I think this was a great event for me because I came here very much interested in seeing what's going on here. 10 years earlier, I was more linked to other people, but still, I think it's worth investing here something. And I have seen the students; they are quite eager, and for each country, for Germany, other countries, Chile, other countries, I think research and universities and education, that's the key. So the key issue is education and learning, and then not trying to finish very soon, but taking the time to understand things and being so that if the students come out with the 21 years or 22 years, that wouldn't work. They need to have some silence, closing the door behind them, do something, work something. Learning needs time. You know? We have a lot of interest in the students because presently optics is what we call an enabling science. So you don't see much optics somewhere in your daily life, but if you have a smartphone, not the camera, but the electronics in the camera is only possible because there were awfully good machines that do the semiconductor exposure and do the metrology, optical metrology, optical inspection. So optics is everywhere, even if you can't see it. And he took care of me like a son. He had 4 daughters, and I think I was like his son. And he always wanted to push me to become better, which was very difficult because he never was satisfied with what I did. So I learned a lot. So if you have the students, you must ask them critical questions, but keep them healthy and not nervous. And so that's what I learned. By the way, he was very critical. I think a good teacher is a teacher which cares about his students. He wants the students to learn something. He wants the students eventually to know more than he knows. So that's the aim of a good teacher. And of course, a good teacher must be a good researcher. So he must be able to find important questions. This is not possible for the students. The students, they are not experienced enough to find important questions. So if your teacher, your professor, is doing research on completely uninteresting things because he did that for 40 years and he doesn't know anything new, so it's very bad for the student. So he will do unimportant research, nobody will care. So Einstein said the most noble duty of a good researcher, is to find important questions. So working on something where the people come on Sunday evening because it's so interesting that they want to solve a problem. That's the trick. That's the trick. The professor, a good professor, never has to say, "Where have you been yesterday?" A good professor does good things, and the students come because they are interested to do that. I think this is a very difficult question. By the way, it's the same question than before. So a good scientist has to find challenging questions, and finding challenging questions is really difficult. I gave 2 talks here at the conference, how to find challenging questions, and I don't want to repeat myself too much, but the one is looking for things that don't work or could work better. So why are these things you are doing, why are they not working better than they are? So that's a question. Then you can do things better if you understand that. Huh? And the other thing, of course, is if you are strongly connected, or if you're connected with the industry and they know your telephone number, they will call you and say, "Look here, we have a problem." And this is an option to find important questions. Maybe not the question which changed the world, but which helped the industry. And that was a recommendation I gave some people here as well. Find out what the industry would like to solve. There was a metrology problem, or what classification or identification, or sorting. So, but that means you must develop the feeling of how the industry people are thinking.
Yeah.
Because when you come as a professor and tell them what to do, they will not work. The first thing is that a professor has to learn to listen to the industry, and because it's completely different. The industry, but if somebody is coming, maybe a small company, they want to measure something, they have a problem, they fear. They are under pressure, they have not much money, they need the solution urgently, and if you start to promise things which you can't hold, can give them, you're lost. So you must be very serious and start to listen carefully, talk to the people, because it's different. In the research, you go to conferences and you talk about your things, and everything runs nicely. Look here, I had this result. But this is no industry person would say, "I believe you." They would want to see something real. Huh? And so, being in contact with the industry, or people from the industry, it's always people, it's not the industry. People on the other side. That makes you modest. So you learn to be careful, modest.
down.
You cannot claim you can change the world. Huh? One has to learn that. One has to learn that. I remember very well when I started this, I was not experienced, and I said the wrong things. I promised too much and so on. So I always tried to do basic research, to find things which are really new, but much of this was triggered by questions from the industry. I think nearly all of my patents were triggered by people who had a problem, which was unsolved. And it's really unsolved. Not only in this company. It's I mentioned it already in my talk here. I got some object on my table which nobody could measure. It was a very nicely polished tap, T-A-P, and was nicely polished with small errors, and I know very difficult. And I put that aside, and 2 months later it arrived again, and then other people told me I had the same tap and nobody knows how to solve that. And then I thought, if it's so nobody knows how to do that, then it's worth to do that. And then we invented the what we call deflectometry. But that was not when I was a student. That was I was an experienced researcher already.
At the time.
Yeah. What you ask me, what can you recommend? Of course, is a thorough knowledge of what you are doing. So a good research, good lectures, so you know what you are doing. Unfortunately, science, for most people, science is not well defined. They have a very diffuse image of what science is. And it's not that difficult to define science in a very few words. The basic idea is that science is always, a scientist is always critic against himself. So just to say, I have a hypothesis, it works, and I do something, and really it works, this is not science. Just show a picture, oh yeah, somehow one could see something. Science is if I ask, theoretically I have to ask, how can I prove that my hypothesis is false? Falsification, that's a very famous principle. But in the daily life, it should work as well. So you shouldn't say, oh look here, I have a nice picture, I can measure 1 micron. You said, why can I not measure half a micron? Or why is it really true that I can measure 1 micron? What is the noise? What is the dynamic range? What is the resolution? Did I pay for it? Commonly, when you do some improvement, then you lose something somewhere. So it's very easy. Science is when a student tells me, or some researcher tells me, I got some wonderful result, then I stand back and say, and tell me what is the disadvantage of your method? Yeah, it's not to blame him, but this is scientific thinking. So I could improve the resolution, but unfortunately I lose dynamic range. That would be a good answer.
Okay.
Commonly people don't ask themselves, what did I pay for? Nature never gives presents. Nature wants something. I have many advices, because after so many years, the first is you should have a good teacher. That's very, very important. I owe my teacher, which was a very famous person, a lot, because all what I learned by him. It's not only optics, it's how to behave, how to motivate people, how to keep the people interested. I think that the first advice is try to find a good teacher, but that's not easy.